Welcome, fellow building science enthusiasts. This is the Kansas City BS and Beer monthly get together virtually. We're fortunate to have Rob Wadsack of Fine Homebuilding helping us out by hosting the webinar for us, and also fortunate to have two excellent guests. We have Josh Edmonds from Simple Integrity up in Cooperstown, New York. Say hello, Josh.
How's it going?
Nice to have you, man. Thanks for doing this. And then we also have our friend Neal Ezell, who you guys have probably met at the local meetings before we went virtual, who's just in Lawrence, Kansas. Say hello, Neal.
Hello.
Well, I was just talking to these guys before we got on about why we don't see a lot of foundation insulation detailing in our market. And those guys will both get into that a little bit in their presentations, but it's been a frustrating topic for us here in the Kansas City area and kind of throughout the Midwest for a variety of reasons. We think, for the most part, what we don't see around here is people looking to go way above code. And since most of the local authorities having jurisdiction have amended it out of the code that they enforce, there's really not a call for it there. So it's kind of down to the builders. Well, do I want to try to sell this to my client? And a lot of times builders are competing on price. So if your client's not expecting it, and you're not pushing them to do it or just including it and not talking about it, it gets to be a tougher sell. The other thing that we have to contend with, and this is something that these guys are going to be great detailing out the ways around this, we have termites all throughout this area. So if you were going to do, say, an exterior insulation package on your foundation, you've got to figure out a way to either keep the pests out of it, make sure that that insulation is something that termites won't eat, or make it removable for inspection purposes, which I know is a strategy that Nathan Shirai down in Tennessee does. But I am more interested in what these guys have to say, and I'm sure that's the same thing that all of you are saying at home. Let's get on to the guests. I actually did not ask Neal or Josh who wanted to go first. Did you guys already sort that out?
No.
Well, Neal, you want to go?
Sure, I'll go. I'm a builder. I used to be a physicist, and I used to work at NASA, and our family has been in building forever, and so it was natural that I end up back at it, even though I went to college to get out of it, but you know it's hard to fight, and so here I am back building houses. Our company builds houses that usually rank between 46 and 53 on the HER scale. I mean, before solar. So anyway, so I wrote an article here not too long ago that was on Green Building Advisor about slab edge insulation, and these guys wanted me to talk about it on this deal. And so I've got a little PowerPoint about it, and I'll just get started. So slab edge, and here we're in Lawrence, Kansas. It's in climate zone 4. We're kind of in an oasis of building codes. We have the strictest codes in the state of Kansas. And so when we first started adopting this stuff, a lot of the contractors had some really unique methods to try to appease the building inspectors and get by. And it was really a shock to everybody in the industry, and everybody approached it from different ways. And that's why I wrote this article originally. I wrote this article like 7 years ago, and it just recently got printed. But anyway, where we are, it's being used way more frequently, and it's almost never done right. But slab edge is a huge, as we'll show in this presentation, it's a huge energy savings, but most importantly, a huge comfort improvement if you live in a slab home. So I'm going to start off by what the code says about slab edge. So the code prescribes in our climate zone R10, which is like 2-inch XPS or 2 3/8" EPS foam to a depth of 2 feet. And it allows you to chamfer the top at 45 degrees to allow for drainage if you want. But that dimension is measured from the top of the slab down. So these pictures here are an example of vertical slab edge insulation. And then it can get a little more complicated. You can go to a combination of vertical and horizontal. And if you have a heated slab, like you have hydronic heat in the floor, the code says R15. Now this is prescribed, it's not required, it's prescribed. So this is what we see a lot in our climate zone is when we first started doing this, you can see each of these examples are not code compliant, but they're real easy because you don't have to protect the foam. You just throw it in the footing, throw it on the ground underneath the slab or whatever, and it's done, and you move on. The problem is that none of these are in any way, shape, or form helpful. It's just the same as if you dug a hole in the front yard and dumped a bunch of foam in it and called it slab edge insulation. It is completely useless. The problem here is that a lot of people think that concrete provides some sort of insulation, which it does not. So solid concrete is about R1 per lineal foot. So this makes a slab edge with a 2x6 wall here. You've got about R.5 on the slab edge. Now, if you think about that, if you take a 2x6 wall with R19 insulation in it, you can almost go 3 stories up before you get to the same heating loss as you get with this little 1 foot of slab edge insulation. So it's a major deal. So here's where we get to the BS part of the presentation, which is, by that I mean building science. This is a computer simulation using a software called Therm, and it's from Lawrence Berkeley National Labs. It's a steady state computer simulation that uses finite element. And what I did is I based this simulation on 25 degrees exterior temperature and 70 degrees interior temperature. So this is an uninsulated slab with a 2x6 wall with R19 insulation in it. So it's an R20 wall basically. And you can see that the corner of the slab right there is about 44 degrees when it's uninsulated. So here in Kansas City, again, it's climate zone 4. Our mean ground temperature is 55 degrees and our footing depth is 36 inches. So on the left here, you'll see an image of one of the errant installations that I showed previously. And you can see that it's exactly the same temperature, 44 degrees, as I showed here, 44 degrees uninsulated. This is insulated with R10, but it's all stuffed down into the footing, and it's still 44 degrees. Didn't make any difference whatsoever. And on the right, this is a really cool image that shows the heat flux. So this is a temperature gradient in the wall, and this is heat flux on the right. And it shows that the intensity of flow goes straight out, right out to the air. So the outside air portion, so if it's 25 degrees, this air is 25 degrees, whereas the ground temperature is somewhat warmer. And then the deeper you go, the warmer the ground is. So it's less important the deeper you go. So here on the left, you have an example of code prescribed method where they take, again, it's a 2x6 wall, but it has R10 down to 2 feet with the top chamfered off at 45 degrees, which which you're sacrificing a little bit right there at the top of the wall, right where you need it the most. And so we get a nice little bump to 54 degrees. Now on the right, we have just 1 foot of insulation. Now this is not code prescribed, but if you're doing a performance-based or a CRI, you can do this and factor it in, and it is actually superior to the code prescribed method, because now we have a temperature of 57 degrees on the interior. So, and here's the heat flux picture of that 1 foot of slab edge, and you can see it, all the heat from the house is having to go under and around, so you have kind of a density here where it's cutting around that foam. But and then you also have some loss through the bottom plate, which is only going to be like R6 right here, R10, and then R20. Or really, a 2x6 wall is R16. So this is what it looks like when we're doing this method. We build a pad, try to keep it nice and level, and then we come in and we dig our footings down to 30 to 36 inches. And when they pour them full, and we try to get them really, really flush to the surface. And then we just stand up our 4 foot of foam on the edge and just zip it off with a Sawzall. Now when the concrete's poured in here, the concrete actually bonds quite tightly to the foam. We don't attach the foam to the form or anything like that. We just lay it in there, and the concrete bites into it. And then we form it up with 2x10s, and we space the 2x10s about 2.5, 3 inches off of the footing, and it gives us 12 inches of foam. So I also ran a simulation using REM design, which it's the neutered version of REM rate. REM rate gives you a HERS rating. This one does not, but it gives you every other thing that it does. And so what I did is I put in 2 feet. So I'm doing a comparison here with 2 feet of foam, which is code prescribed, and it shows the impact on heating costs. Now in our climate zone, there's no impact on cooling costs. We just don't have that big of temperature differential in the summer, and you actually get a little heat loss through the ground, through your slab in the summer, and it kind of evens out what you get in the winter, the heat loss in the winter. But so if you start with a 2 feet at 0%, it's $336 a year annual heating cost. And then when we go to 1 foot, it's about a 4% drop. You lose about 4%. And then the other thing that I push is a lot of guys will not put the foam between the interior and the garage. And you're losing about 13% as compared to the 2 feet all the way around by doing that. And no insulation, it's 44%. So just doing the 1 foot, we gain 40% on heating cost, which is huge. Now I also included here to a depth of 4 feet, R10 to a depth of 4 feet, because as you can see in my picture on the left here, this is a 2021 code that just came out. And in climate zone 4, the 2021 code has changed it to R10 to a depth of 4 feet. So going to a depth of 4 feet, which I'm not quite sure how you do well, I guess if you go from the top of the slab down 4 feet, you're pretty much hitting the bottom of our footing, maybe a little past it. But that only gives you a bump of 4%. So it's not that big a deal. You'd be better off going with thicker insulation if you could figure out a way to do it. That creates a problem since we're cantilevering the wall. Now, when we cantilever the wall like this, what we do is our engineer wants us to bear 4 inches on the slab, which is actually more than a 2x4 wall is, but you know, we're cantilevering. So we flush our boxing to the outside of the foam here, and it works pretty good. So this is actually a slightly different, this goes beyond my article here. This is actually how my own home is done. What we did is we cut off the 1 foot on the outside and then took the remaining 3 foot and flipped it over and laid it down here. So we have a factory edge right here. And so we have actual 4 foot here of slab edge. And then we put another R5 underneath the slab. Let me show you a better picture of that. Well, all right, so the point here is that my entire house that I'm sitting in right now, and it seems to be pretty stable. I've been living here for 7 years, and the whole house is sitting on foam, and it's 25 PSI foam. This is a single story slab rancher, and we have had no issues whatsoever. So the point is that the foam is 25 PSI. So what's weird about foam is they measure it in PSI, its strength, but soil is measured in pounds per square foot. So if you convert PSI to pounds per square foot, you got to multiply by 144. It gives you 3,600 pounds per square foot. Now, over these footings, we're only loading the wall with about 1,000 pounds per lineal foot, which is per square foot. Maybe up to 1,200 if you span and this is all truss. So we're spanning our trusses. Once you span your trusses 40 feet, you might be getting close to like 1,200 pounds. But since foam is made out of plastic, it is susceptible to creep. And so over time, plastic will move, and it takes time, but you put it under pressure and it will slowly bend and move to that pressure. So it's been determined by a lot of studies that if you keep your load factor to about 3-to-1 or 4-to-1, then you shouldn't have any problems. So we're at about maximum 1,200 pounds per square foot, and we've got 3,600 pounds per square foot foam. Now we've done this on 2-story houses, and then we'll switch to a 40 PSI foam, and you can get XPS up to 100 PSI. And so no matter how many stories you're going, you can still use it. Now the 40 PSI costs about twice as much as the 25 PSI, so it starts to get a little pricey. I don't know how much 100 PSI costs. So this is what it looks like before we put all the rock in. Then we put the 1-inch foam over the top. And the reason we're doing that is because here's with the 6 mil vapor barrier, which is what you kind of need to do. It's class 1. The foam is class 2. Still need to put your vapor barrier over the top of it. So this shows my floor heat going through the slab. So my house is all heated with mini splits. And so I need a little boost in the winter for a little extra heat, which is why I did this. And so we have heated floors in the winter, but just 4 loops around the perimeter, real basic. I just run water from the water heater and just have 1 water heater for domestic as well as the floor loops. And it's separated, but we can heat the entire house with just these 4 loops around the perimeter, and it stays very, very comfortable throughout the house. So here's the imaging on this. So now we're up to 63 degrees in here, and I've shot this in winter when it's much colder than 25 outside, and You know, you shoot it out here, it's about 67 degrees in the winter, dead of winter, and it works quite well. And here's the flux diagram. But then the other part of the problem is protecting your foam. So there's a lot of things that can degrade the performance of your foam, from just ultraviolet radiation from the sun, as well as you know, your weed eater or termites or whatever you can think of. Foam's not a really good thing to leave exposed for very long. So a lot of guys around us, they'll use sheet metal and they'll bury the sheet metal down, and then they'll lay it right up the side of the wall. So the problem with that is that the termites can go up behind or through or between the sheet metal and the foam or wherever they want, and they can go right into your house and you never know they're there. You don't see their paths or anything. And so that's not a really good way to do it. Plus the sheet metal, you bury sheet metal, even galvanized sheet metal in the ground, and I'm sorry, it's not going to last that long. It's going to corrode and it's going to fall apart. So so we came up with a different material, and it's EPDM. This stuff is like it's like really thick tire inner tube. There's no way a weed eater can touch this stuff, much less a termite. And so you just poured your slab, and you take a big sheet of this stuff, comes in a roll, and you just lay it out on the slab and snap lines on it and slice it into 16, 17-inch strips. And then we use contact cement, spray it on the foam and on the top of the floor, and then spray it on the EPDM. It dries in just a few seconds, and then you slap it on the side, and you've got termite protection, you've got everything. And when we build the wall, we'll put our regular foam strip on the top and just spraying the wall. And this is what it looks like when it's all done. This is a picture I took just the other day of my house. This stuff actually holds paint really, really well. I mean, that's 7 years old. It looks like the day we put it on. It works fantastic. I've got most of my house, you know, we don't have grass up next to the house, but there's a little spot out back. I just mowed the yard today and weed eated it, and man, that stuff's tough. You might shave a little paint off over time, over 7 years, but still looks good. Still looks really good. But anyway, that's my presentation. But the big deal here is that you have to think about this as a 40% heating loss through one very, very small part of the envelope. So the impact to, if it was spread over the whole wall or the whole house, it wouldn't be that big of a deal. But since it's focused in one area, the impact to comfort is huge. And this method, what I try to come up with is a method that is really, really simple, real cost effective. It's easy, you know. And anyway, this is what we came up with.
That's a solid start for us, Neal. I really appreciate you putting the effort into that. I have a ton of questions, and I know there's going to be more from the chat box, but I think that some of those questions might get answered in Josh's presentation too. So
Great.
Go ahead. I was just going to say, we'll go ahead and jump in with Josh and let him go through his next, and then we'll do a big discussion at the end, just like we normally do, if that's all right.
Sounds great.
Thank you.
Okay. Neal, that was great. I learned some stuff, which I loved. Let me just get my screen to share. Hello, all. I am Josh. I am a builder. I started as a woodworker and a carpenter, and years later there's a lot of us and we build a lot of stuff, and we love what we do. I do this because I love it and I'm lucky to do it every day. I live in upstate New York with my family here. These are my peeps. And I'm a certified passive house consultant and certified passive house builder. Here at Simple Integrity, we have built some certified passive houses, and we kind of specialize in high performance homes. There's a lot of people building in our area, but our niche is really, houses that are performing well beyond code. There's people that like them, and we'll talk a little bit about that, but we'll focus on foundations. We are in climate zone 6. We're in this nice little spot between the Catskill Mountains and the Adirondack Mountains. And so climate zone 6 dips down into climate zone 5. And if you look on the screen, that little star up there is about where we are. And so it's interesting hearing about other climate zones because it's just, I know my little world, which is cold winters and reasonable summers. We don't have a lot of humidity. We don't even have a lot of heat. When it gets to be 80 degrees, we're all dying and, ready to turn on the AC or do something different. So that's a little bit just kind of who I am and what we do. So again, we specialize in high performance homes. And so there are homes that get built that aren't in our area, and those are great. Ours are a little different. But at the end of the day, the basics are all the same. You got to have an air seal. You got to have, you got to deal with thermal, bridging. You need good windows. You need to know what your heat loads are. You need to know what your climate zone is, things like that. And when talking about foundations, at the end of the day, they got to bear weight. They need to give you the ability to have some kind of air seal. They should play well with your thermal envelope, and they should be durable, and they should be buildable. That's one of the things I loved about Neal's presentation, when he led with that he was a builder, and then, just the use of the EPDM is fantastic because it's so easy, and if it's not easy, it won't get done. All right, so what foundation is right? People ask me that sometimes when we start getting ready to build a house, what kind of foundation are we using? And my first question is always, well, what's our wall assembly? Because foundations play differently with different wall assemblies. And we're going to talk primarily about 2 wall assemblies and 2 foundation assemblies that we use. Along with those is, does the house have a basement? We have got, in the past 5 years, we've had a lot of people come to us, and on their list of wishes with the house is they don't want a basement. In upstate New York, we have a lot of old stone basements, which are usually wet, damp, moldy. And so that's what they know. And they're like, no basements. I don't care how well you detail it. I don't want a basement. And so we do a lot more slabs and things like that. Size of the house, usually it may affect what kind of wall assembly or foundation assembly we use. Budget, some of the assemblies that perform better cost more. And so knowing the client budget will generally steer us in one direction or another. What's the soil like? Do we have any issues with bearing capacity and things like that? And also, what's the water table? If you have a high water table, we're definitely not going to sort of push them toward a basement or something like that. So the 2, main assemblies that we do are double stud walls or Larson trusses or exterior insulation. In some of the lower climate zones, you can get away with, 2 inches of exterior insulation, things like that. Up here, we're usually, a lot of the houses we build have about 12 inches. It's just a difference, with climates. And each of these assemblies play better with one of the foundation assemblies. And so we're going to talk a little bit just about both of them. So the double stud wall, we pair with a traditional 4-foot frost wall with a footing. The only real key to this is right here. I don't know if everyone can see my mouse, but where we have our sub-slab insulation, it wraps up in between our 2 walls and creates sort of a thermal blanket that is continuous. It's under the house, and then it comes right up in between, and it connects with our insulation that's between the walls and goes right up and then over the roof. This is an easy foundation system because our concrete contractors are used to doing this. I mean, it's basic footings, which is nothing new there, and it's concrete, which is, everybody's used to that. It's durable. We don't have to deal with exterior insulation on this one. The concrete, I mean, you can ram your lawnmower into it. You can do whatever you want, and there's really not a lot of damage. It's sort of bulletproof. But it only really works with this double stud wall because it allows us to place one wall right here on the concrete, and then the other one sits on the slab on the inside. And as Neal was talking about, this particular assembly uses that 25 PSI foam, that XPS. And so there's no issues with bearing. Everyone usually mistakenly does what Neal pointed out, where the foam is measured in PSI, whereas a lot of other bearing capacities are measured in pounds per square foot. And so once you convert the two, suddenly it's like, oh, well, yeah, I guess we can put a little 2x4 wall on the foam. This assembly, I'm not going to talk too much about the actual wall assembly because I know we're focusing on foundations. But I guess the key here is we have that thermal layer in between the walls, and it's protected. And it's easy, and there's not a lot of labor involved, which again makes it buildable because we got to be able to do this in the field. So it's sort of a real nice assembly, not a lot that can go wrong, and not a lot of issues for callbacks, which again is a big thing. This is one of these foundations going in. You've got your poured frost wall right here. And then here we're doing our sub-slab insulation. In our climate zone, up in climate zone 6, sub-slab insulation is really important. It'd be a very uncomfortable house if you didn't have it. The temperatures that you'll see when Neal was kind of pointing out with the therm modeling, condensation becomes a big deal, because any cold surface in these houses in the winter, you're going to have water literally pooling, and it takes the customer about 10 minutes before they start calling you and saying, hey, I got water on my floor, I got water on my window. I mean, condensation is a big deal. And so you can talk about the energy savings, which I'm a huge fan of, but people don't call me as often in the middle of the night with, hey, my oil bill was $12 higher than I expected it to be last week. What's going on? I get a call really fast if there's water pooling somewhere. And so slab insulation is kind of critical to that, because any surface that starts to cool off is going to instantly condense. And then you can also eventually end up with mold, which again, is a phone call, because nobody wants mold in their house, and nobody should have mold in their house. So this detail here, this house, I believe, had 6 inches of sub-slab insulation. Code up here is probably 2. But when we run the energy models, we can find a sweet spot between cooling load and heating load, and it's usually around 6 inches in our climate. If you go more than 6 inches, your cooling load actually starts to climb, because you're not able to dump any of the summer heat into the ground temperature. But if you're at 4 inches, you'll have a substantially higher heating load. Your cooling load will be low, but our cooling loads are usually so low that it's not a big issue. In this slide right here, you've got your outer 2x4 wall here that's sitting directly on the concrete. And then this little strip right here is your 2 inches of XPS that's coming up in between the walls. And then you've got your inner wall here. And so once this wall is filled with insulation, we usually do a combination of closed cell spray foam for about 4 inches on the outside, and then dense pack the rest of the wall. And so then you have a really nice continuous thermal break on the whole building, and that wraps around to the attic. And so you end up with a nice insulated box, and then you can dress it up with the windows and the roofs and the siding and everything like that. But it's a nice, easy assembly. The other type of assembly that we have started to do frequently, this is a little more like Neal's, except tailored for climate zone 6, a frost protected raft slab that we pair with usually a Larson truss assembly. You can also do it with exterior insulation. This assembly can be modified down to 4 inches of exterior insulation as opposed to something like a foot. When we started looking at different foundation systems, because in our area, there wasn't a lot of other people doing anything different. Everything was sort of how it has been for years. The type of things that Neal is seeing where people aren't even insulating the edges of the slabs and things like that. We'd have people pour in concrete basements with no wall insulation. And that was sort of normal. And it was like, wow, that's a lot of heat loss and that's just uncomfortable. And, you know, as we started getting into different wall assemblies, they needed to play well with our foundation assemblies. And so that's why we moved to this. And the couple things to think about when you're looking at foundation assemblies is, one is prep. Chances are an excavator is going to be doing it. And so it's got to be something that works well for him, because if it doesn't, you're going to get pushback. And if you have 12 different, subgrade elevations, it's going to get expensive. And when it gets expensive, then nobody's happy. And so prep is a big thing. The height that your building is going to be above grade is something to know and to understand. The thickness of the frost skirt, which is in a frost protected slab. Here in climate zone 6, we have a 4-foot frost depth. That means that our footings need to be 4 foot or below. Otherwise, they run a pretty high risk of heaving. But you can mitigate that by running a horizontal frost skirt, which we have found to be quite useful. And that's what we have here in this assembly. Your subslab insulation is good to know. Again, like I said earlier, we generally do about 6 inches. And then exterior finish, which is something that Neal touched on. That's something that's also kind of a factor, and I'll kind of walk you through what we do for these. So this is one of our standard frost protected wrap slab assemblies. It starts with these foam blocks right here. They're a foot thick and they're 2 foot tall. And the excavator starts by scraping off the top soil and giving us an elevation 3 foot below our finished floor height, which is usually 2 foot below grade. If we jump back here, this is our finished floor height right here. And we usually show a foot of the wall, and then the bottom of our foam blocks are is a foot below grade. And so there's a foot of crushed stone. You can get away with 6 inches, but the big thing is you just want to have a nice compacted stone base with drainage. And then we stack these 60 PSI EPS foam blocks, and you can actually screw them together with structural screws. You can see them here. And it's just like putting together like big Legos. It's pretty easy. You know, we've got a nice big flat stone surface, and we just plunk down the perimeter of our building. You can cut them with a circular saw, and you kind of just tack them together in your perimeter. They hold together enough that you can set your square or whatever shape, and then you can pull one corner to sort of adjust the other corner to get everything just right and square. And then we use a grade beam at the edge of our slab, because our structural 2x6 wall is going to sit on the edge of that slab. And so we've got a little rebar grade beam that just helps spread out the weight. Under the slab, we use 40 PSI EPS foam. It all comes from the same manufacturer. And when we started looking around for these types of slabs, we talked to our local lumber yard, and he was like, yeah, I can get you EPS, any PSI, any thickness in about a week. We're like, wow, hey, you know, that works for us because it gives us flexibility. And so as we slide forward, these are our lovely foam blocks that make up the perimeter. And here's another prepped slab. And like you can see, this bottom base here is what we set the perimeter foam blocks on. The excavator has already begun bringing in the gravel on the infill side, because if our foam blocks are 2 foot tall and our slab is 6 inches deep, and we've got 6 inches of insulation, we've got about a foot of crushed stone inside. And these foam blocks are also going to act as our form for pouring the concrete. So it kind of serves double purpose. This is what a typical delivery looks like. It shows up a whole lot of foam, and then, you know, in about 2 days, it's all gone. So the process starts just like this. We have a nice foam, a nice gravel base. And this is a tiny little house. It was about 600 square feet, little square. It was simple, but it was what they were looking for. And you just set them together and you screw the ends together with 18-inch structural screws, just like that. The intermediate blocks you can just tack with 8-inch structural screws, usually about 4 of them, and it holds it real nice. For our outside, I had never thought to use EPDM. That's kind of a neat idea. We use Durarock. It comes in 3x5 sheets. We rip it in half so it's 18 inches wide, and then we use thin set, and we stick it right to the outside of the foam, and then we just tape the joints, and then we go back over with block bond and parge it. So when it's done, it looks like you literally have a concrete foundation. And so you can weed whack it, you can kick soccer balls against it, you know, you might eventually damage the parge coat, but you've got 1/2-inch Durarock that's stuck right to the foam. And it really helps stiffen up the foam because you've got a continuous layer of thin set. We don't have termite activity in our area, but that's something we still try to be cognizant of. And any activity that I've seen usually has some above grade activity. You know, if you have foam exposed, the ants will start to get into it. But I've rarely seen a lot of activity below grade, which I think is why, you know, the same with Neal's climate, they run the EPDM 6 inches below grade or something like that, because it seems to mitigate all the foam activity. And so it's the same scenario here. We've got Durarock running 6 inches below grade. So in this slab area, it's all prepped, the gravel's in there. And then we put our poly down. This particular house, we usually do poly on top of the foam. A long story why there's poly below here, but it had to do with the EPA Indoor Air Plus certification, clashing with Passive House certification. And there was like 7 different certifications on this project. And one of them wanted one thing and the other wanted another thing. And so eventually everybody was happy, but we'd usually put the poly on top of the foam, especially if it's gonna rain. But here, we got our poly, we're doing all of our sub-slab insulation. We usually do 2 layers in our climate zone and stagger the seams. Second layer going down. And on this project, again, it all had to be taped just for some of the certifications, but often we'll lay all the foam and then put the poly on top. And the poly wraps up and out of our slab because that's part of our air seal. And you're gonna see that tying into the building. Real world conditions. Sometimes it's muddy, and this was just before Thanksgiving a couple years ago, and it was about to snow. Yeah, it's fun. And what you're looking at here, well, for starters, start them young, teach them how to walk the plates. But what you're looking at here is your poly that's gonna be part of our air seal. And so right now it's draped over, and we're getting ready to frame walls here. And then once our zip sheeting goes on, that poly will get taped to the outside of the zip sheeting to complete our air seal. And our air seal is that zip sheeting that then runs up the walls. What you're looking at here is you can see that 1-foot foam stem wall with the Durarock on the outside. And then you've got the poly taped right to the zip. We have 12-inch Larson truss on this wall, which we use 12-inch wooden eye joists hung vertically for. And so our window bucks stick out 12 inches and they're air sealed to the zip. It keeps that air seal layer buried inside the wall. Not really the foundations, but it is what it is. With those foam blocks, they go together really nice. If you ever have a crack, we just use gun foam and just tidy up the crack so that it's sort of continuous. You have no air movement, which again, you'll get those little pinpoints where you'd have a cold edge or a cold spot. This is an example of one with all the sub-slab foam put in. You can see that all the parging has been done all the way around the building. You've got that Durarock on. It almost looks like concrete. And what's nice about this is it's one pour. So when the concrete guys, they have yet to show up here, and this is how we have it ready for them. They show up, they don't need to brace anything because we've backfilled on the inside and the outside of those 1-foot thick foam blocks, and those are rigid and they don't move at all. And so they just show up. We usually leave them the plastic. so that they can roll it out, because if we put the plastic in, it fills with water. It's just a pain. So they roll out the plastic, they drop all the rebar and the steel mesh in, and then they pour concrete and they screed it right to the top of our foam blocks. And that way they're there for usually a couple hours to prep and then one day to pour, and they're done. And so they love it. They just can't wait to come and pour our houses, which is never a bad thing. You know, we don't have to argue with, you know, hey, we got a nasty job, can you come do it? And, you know, they drag their feet. So it works well. What you're looking at here is you've got the wall framed up, you've got the window bucks on, and you've got this 1 foot step of that foam insulation right before the I-joists are about to get set onto the outside of the building. In this photo here, you can see exposed foam here, but the thin set is going on, the Durarock is coming behind it. You can see the sheets laying on the ground here. And then on this side, the Durarock's already been applied. And so they're running behind and parging it. Inside, this was a busy day. Inside, you've got the gravel prepped, you've got the layers of foam going in, kind of everything going on at once. This is a photo I took a day or two ago on one of the projects that's under construction. This is the Durarock. You can see the rain screen has been put on, the wooden I-joists are behind the membrane. And so it looks like a concrete foundation. And so it's kind of great. It keeps us happy, and people aren't, you know, wondering, wow, why am I looking at foam or things like that? And it's really durable. It is able to carry weight. The I-joists are fastened vertically to the building at the same time. So it's not that a lot of weight sits on it, but it has the capacity to handle a ton of weight. The 60 PSI was a little more expensive than the 40 PSI, but it holds the structural screws really nice. And when you look at the buildability of it, it made a lot of sense and was worth the money because the foundation goes together so fast. This is just another shot of sort of the foam all going together, and then kind of what the building is sort of developing into. Another shot of that, you can see the concrete's poured with some of the framing starting to go up. And so at this stage, it just kind of looks like a regular slab. And I guess sort of the whole thought behind all this is these are just some samples of some of the data for some of the houses that we've built here. And some people look at this and are like, wow, that's a lot of overkill. And it's like, well, 12 inches of insulation, you know, at the slab edge, yeah, it probably is, but it works with our wall assembly. And when we look at these, you know, 18-inch walls that we're building, they average out to about a 3% increase in cost for us as a particular company. And a lot of that is driven partially by the fact that if the houses already have nicer finishes, the price tag is higher. And so that 3% is a bigger number. But in our climate zone, when some people are looking at heating 2,000 square foot houses for $6,000 or $8,000 a year, we can turn around and have a 2,600 square foot home that heats for $254 a year. You can start to recoup your costs pretty quick. And that's sort of one facet, but the other facet is just the sheer comfort and durability of these buildings. I don't care how much money you're going to save or lose heating a house. If your floor is condensing or is freezing and uncomfortable, it's just not an okay way to build. There's just, I don't know, levels of, I don't know, everyone has different standards, but you know, when you look at code and things like that, it's just important to, you know, as builders that we're looking for better ways to do things. And it's going to vary for every climate zone. Our climate zone just happens to be cold. And so when it's negative 26 degrees out, it's no joke. And, you know, you got to sort of be ready for that. And sometimes it'll be that for a while. Sometimes it'll be 0 and just stay like that for a week or two and then climb back up to 15 degrees. But it's usually pretty cold. And we have a long heating season. We don't get a lot of sunlight in the winters up here, as opposed to some places like Colorado where they'll still have a lot of sun. And so kind of all that wraps around to that foundation discussion where you got to have something that's buildable and you got to have something that works. For us in our climate zone, we have to have like a complete thermal blanket. and figuring out how to connect that foundation system to a wall assembly has been kind of a critical piece. So those are my thoughts.
Excellent presentation, Josh. I have not ever seen that much. That's an awfully deep slab edge insulation detail, but I also have never been in -28 for my winter, so it does make sense. The parging really is convincing. Like, if you had just shown that picture at the beginning, I would, yeah, why didn't you insulate your foundation like we're talking about? I don't understand.
Yeah, I mean, you don't have to do 12 inches. You know, let's say you did 2 inches, and then you put the parge on it. The Durarock, I think, is kind of a key to that, though. I've seen foundations parged with just like a block bond, and you kick your soccer ball against it, and it cracks, and then you've got exposed foam. So, yeah.
Not having the termite issue to deal with is a big win there.
Yeah.
Because that would obviously for us is a really giant hurdle to overcome. And I was trying to think of a really clever way to cap that, and I don't have anything. I'll leave it to you guys to solve that for me. I'll probably do it Neal's way since I'm in his backyard, but man, it's cool to see that stuff come together, and to see those super insulated houses they're just gonna perform so much better than what we're seeing in most of our market.
Yeah, you definitely don't have to go all the way to like say passive house level, which some of those 12-inch walls, that's all passive houses, and you could build an amazing house with 2 inches or 4 inches of exterior insulation. It's just a matter of kind of modifying the assembly.
Sure.
You know, one thing, guys, that that seemed to be a common theme in both of your jobs is that as soon as you see that picture of the insulation and the forms prepped for the pour, you realize how tidy and easy of a project getting that slab in there is. And so in a lot of ways, you're making the job easier by making some smart decisions about how you're detailing your materials. And so you can see why a lot of people think of building super insulated houses. Oh, you've got all these extra steps and all this extra materials. But if you make your choices wisely, it lessens that gap.
Yeah, absolutely. And I think that's, I think Neal and I both coming from a builder's perspective, we've built a lot of these. And so, it's one thing when you design something, you've never tried it, but once you've done it and, if it makes sense and it's smooth, you do it again.
So Travis, do we want to have Dan jump in and talk about his stuff quickly here?
Yeah, our friend Dan Edelman, who's a great guy in Pennsylvania who's done a lot of stuff with Rockwool. He was mentioning that he's got some non-foam options to share as well. And I've worked with the Comfort Board a little bit, but if we can promote him, he's got some details he could actually screen share and probably explain a lot better than I could. I'm not super savvy on the Zoom platform.
Oh, he's all ready to talk. I think he's just waiting for you.
What do I need to do?
Are you there, Dan?
Yeah, if you guys can hear me.
Yep, we can hear you.
Share a screen. So you should all be able to see my screen at this point. So again, a lot of the, I think the biggest thing with starting at the foundation is just continuity, and it all starts from the bottom. So by keeping the air barrier and the thermal barrier starting at the base of the structures, you're then going to basically work your way up from the house. So everybody always says it starts with a solid foundation. Well, now it's starting more with a insulated foundation. So any of these designs that Josh and Neal were talking about are obviously they work. And they all work, but if you are looking for a foam-free kind of avenue, I know there's stone wool, mineral wool products that are out there, board products that you can do sub-slab. So on the screen now, here's a couple details. With mineral wool options, we do like it better when you're putting them on the exterior, mostly because we're not an air sealing product. So by simply putting it on the outside, you don't have to worry about the condensation issues on the concrete that you would if you put the rock wool on the inside, or I'm sorry, stone wool on the inside. So you can see the two different ones. And I actually have some cool pictures from Travis. And this is basically, you know, easy 3 steps for the insulation portion. Now the air barrier or the polyethylene plastic would go on top of the mineral wool insulation here. And I actually have your video still linked in here for your time lapse. I don't know if videos sometimes get delayed.
You're making us look really good, Dan. Yeah, Joe and I were able to knock out that little 560 square foot addition in like an hour and 15, including loading the material in. So the sub-slab stuff, it's really easy to knock that out quick. I don't know how that compares with EPS installs or XPS, but the cleanup was the favorite part. You know, no foam beads to pick up and no saw, just the hand cutting goes very quickly.
Yeah, and you could see Travis in here cutting with just a regular serrated knife. So I have seen also turkey carving knives being used. One thing that I like, I've been seeing a lot more and more, just people insulating around their foundation, whether it's code or not. And one of the biggest other trends that I kind of heard was the termites, and stone wool is naturally termite resistant. So you don't need to do any other protection. Now you do want to do like a dimple mat on the exterior, just to really keep any kind of forcing water or mud really getting into your the insulation, really clogging the pores, so to speak. So yeah, you see Travis putting that in against the old rubble foundation, very tight. So that's all that I really had, guys. Thanks for letting me chime in.
Thanks, Dan. I wanted to ask you before you go, though, on that exterior detail, there was like a metal flashing break in between. Yeah.
Yep.
Oh, that's at the base of the wall. Sorry. I understand.
Yeah, so what we like this flashing. Now, you don't, I mean, you're going to get some moisture condensation or whatnot in up here. Instead of it going all the way down to your French drain, we're saying let's dump it out while it's still outside and can dry a little quicker.
And that's why the interior insulation there at the rim is so critical. Yeah, this is such a, this is an important topic, because I noticed Armando was just bringing up in the chat that we need to talk more about crawl spaces and basements for this, because the reality here in my neck of the woods, we see very, very few slabs. I know that they can be very efficient, and a lot of the high performance builders prefer them for good reason. But for ease of mechanical access, for abundant storage, and you know, a number of other reasons, it's extremely common here to have full basements on almost every new home. And then for most additions, what we see are conditioned crawls. So these foundation insulation details really rely heavily on that connection down at the bottom of the wall, if we're going to talk about continuity. And I know, Neal, you and I talked about that some this weekend, so you might have something more to address with that.
Well, and Travis, you also have something called tornadoes out in Kansas, so you need to hide in a basement for those. I grew up in the Midwest too, so.
You know the deal.
I know.
We have storm shelters. But conditioned crawls are usually a lot more expensive than a slab.
Yeah, that's been my experience too. And even with basements, just once you're stuck insulating and sort of all the other details that go into that, that's the only reason why we don't do more of them, is just because it used to be that attics and basements were super cheap, like extra space, because they weren't really finished and they weren't really insulated. But the types of homes that we're sort of shifting to, where we are insulating basements and, you know, we are insulating attics, we're not just making it a bonus room with, you know, draft gear, things like that, that it's added a fair amount of cost. And, you know, that's kind of why they've shifted out of our market. The mechanicals issue is sort of a valid thing. The only thing we bury in our slabs are the waste lines. Everything else, we have a neat mechanical chase that is inside our air shield envelope that runs up at the ceiling. And mechanicals have really gotten pretty clean and pretty smooth. But, you know, it took us a few years to kind kind of figure out some of those details. But you know, yeah, those are kind of great points. And honestly, we do basements occasionally. And honestly, it's usually details somewhat like what I'm seeing on the screen here from Dan's screen. You know, sometimes you'll see foam or spray foam, but it's usually a combination of trying to run exterior insulation down past and bring your inner wall insulation up, and just try to sort of have them cross so you don't have what Neal was showing with that slab edge where you have that really cold spot. But yeah.
Yeah, that's what we do on most of our stuff is we put faith in the magical transfer, you know, the magical interior insulation that just somehow works its way back into plane with the exterior insulation through that rim joist cavity. And we basically lap over the mud sill on the interior side, fill the cavity at the rim. And so we're trying to knock it out there, but ideally you would always insulate at the cold side, you know, outboard.
Yeah.
So how are you solving that, Neal, as far as your plumbing penetrations and other things? I know if you're heating and cooling radiant, you don't have to worry about your duct work, but I'm curious how you're dealing with that in Lawrence.
Well, we use spray foam on everything, so that's kind of like cheating. I mean, we can get away with a lot with the spray foam. Our houses, I mean, I saw your blower door test was at 0.13. I think our best ever is like 0.68. I was pretty proud of that. That was my house.
That's a good blower door number. I mean, that really is.
Yeah.
And maybe for another discussion, but yeah, our air seals are usually 0.3 or under, and that's without really spending a whole lot of time. It's designed into the assembly, and it's part of it is, you know, it's kind of, we make a square box that maybe have a couple bump outs or something, and then we put a roof on top of all that. And so we start with an airtight box, and all of our mechanicals run inside of it. The only thing we poke out is like vent pipe. But yeah.
I think that's a valuable conversation. This is a building science discussion group, man. Tell me about how are you transitioning your air seal? Obviously, we saw the polyethylene at the slab, then taped up to the sidewall and transitioned to your zip. But the ceiling, that top plate is always the nightmare. Are you doing Intello across the ceiling? What are you doing up there?
Let me grab the screen back. All right, here we go. So we're in SketchUp now, and I think I have, here we go. If you can see the screen, what you're looking at here is the double stud assembly that we saw earlier.
Yeah.
And so we have our zip here. That's our air seal running up right up the outside of the building. And then right here is kind of a detail that we pretty much use in all of our houses now. We use wooden TJIs, and we set them right on top of the wall, and they go right across the whole building. And we use acoustical caulk to seal our wall zip to our ceiling zip, which we run on top of the TJIs. And we literally build an airtight box. It's a box. There's no trusses sitting on top of it, and we could blower door test it then, and it'll test as low as it's going to test. All of our mechanicals, so water lines, HRV ducts, lighting, electrical, it all runs up in this nice TJI chase. We've tried 2x4 chases, but they get vetoed by me and the guys in the crew because they are a pain. And honestly, I think it's cheaper for us to do the I-joists over the 2x4s when you factor in labor, because we can get dried in a number of days earlier than if we were using our trusses to dry us in. Because, I don't know, the weather, we're all building in the weather. I mean, some days it's nice, sometimes we have a great stretch, but sometimes it rains for a week. But here, we can put the walls up, put the wooden I-joists across the building, and then drop our zip on and tape it. And at that point in time, we are pretty watertight, and we can start running mechanicals inside and then just frame during the nice weather. Or we can split crews and have one crew framing and one crew running mechanicals inside. And it's really nice when we put our insulation up above. we're not really running any mechanicals in it. So we're not digging through the insulation if we have to fish a wire or anything like that. It's all kind of nice and tidy inside a ceiling chase there. In this detail here we're looking at that Larson truss wall. This was an assembly we did a number of years back with that 2x4 cavity that everybody hated because you couldn't hit the Zender HRB ducts and have them cross a water line. And so it just became a nightmare, and it worked, but we went back to the TJIs. But again, same concept. We have a flat zip ceiling. It's hard to damage the zip. You know, you're not going to bang it with a hammer and suddenly poke a hole or something like that. And again, it's easily available at the lumberyard. So that's kind of what drives some of those decisions. But, you know, with that assembly, you know, between bringing that poly up, taping it to the zip, and then the zip just runs all the way across the building. And so without a lot of work, you end up with lower door numbers that are predictable, you know, below 0.6 ACH 50. We've kind of gotten comfortable enough that it's in the contracts, and it's a big problem if we didn't have a blower door number that was tight. But I don't know, we've done enough of these that it's really not a question. If you just make sure you stick the zip tape on and you roll it, it's hard to go wrong. So we like simple stuff.
Before we go too far away from that, Josh, there was a question in the chat, just confirming that's a ventilated attic or a cold roof there.
Yes, so those are ventilated attics. That's our favorite type of attic. If we had to pick, we'd build square boxes and put a truss roof on top and ventilate it and just do loose fill insulation. It's inexpensive. You know, loose fill, you can get a high R value for not a lot of cost. We just use loose fill cellulose in the attic, and you know, it's been around for so long that it's a really problem-free assembly. So if you're doing an unvented or something like that, completely different assemblies, and yeah, that's a different thing.
Neal, how are you solving that? Are you, as far as your air barrier detailing, are you running zip also, or what's Ezell Morgan's plan? How do you guys, you're obviously pretty well detailed at the base of the wall. We've gone over that, but since we're talking walls and ceilings, why not talk walls and ceilings?
No, we just use regular OSB. I love that product. It's fantastic. It's very, very heavy and very expensive, but yeah, we use regular OSB with a good vapor barrier, with a good house wrap.
Okay, so
But
the house wrap's your
we are
WRB to protect that OSB, but your spray foam's really your air barrier then, right?
It is.
Gotcha. Yeah. Okay.
So the house wrap is our water barrier, and we detail our windows very, very carefully. We slant our sills and we wrap our sills very carefully. We haven't had, oh my God, I can remember building houses back in the 90s and all the callbacks we used to have, and we don't have callbacks anymore. We just don't. It's fantastic.
That's the way we like to run as well.
People don't, or builders don't factor that into their equation very much. I mean, nobody likes doing callbacks. And the only callbacks we have is when I just had one the other day, and one of these tankless water heaters fails, and you got to call the 800 number and figure it out. That's our biggest problem.
Well, that's not too bad of a problem. That's usually pretty manageable. I don't know if there are other folks that have more foundation insulation questions. Be sure and throw those up in the chat. Again, I'm a crummy host. I didn't introduce that in the beginning, so for sure throw those in. I had a couple things I wanted to kind of follow up on from way back when with Neal's presentation. I was wondering if you had ever run the numbers, to delineate the performance change if you did run basements. I guess if all you're doing is slabs, you probably wouldn't have done that. But as far as like your percentage improvement graph is really valuable, especially if you're sitting with a client at the table talking about, I'd like to put $5,000 in the dirt so that you can get that money back and be comfortable for the next 25 years. Since I'm probably going to be stuck with basements, I'm wondering if I can get you to run those numbers for me on tall walls.
It's funny, but basements and slab edge is very similar. Very
Okay.
similar. We don't really have, it doesn't get cold enough here for us to have really much of a condensation problem once we get below grade. I mean, you go just a little bit north of us and you do, okay? But we really haven't seen much. We're more worried about wicking from the footing into the wall at the base. It would be better off putting some waterproofing on the top of the footing before we pour our walls. But as far as temperature causing condensation, we really don't have that. But if we can just insulate the top four feet of our foundation walls, it's about like my deal on the 1 foot of insulation on the slab. It's about 95% as good as going the full 9 feet on the basement wall. Maybe 85% is good. So that's what's in our code here in Lawrence, which I wrote. But if you do it on REM design, again, it confirms it. But we've seen it over and over. It really works well. But you take a basement wall that's completely uninsulated, and it's a huge hit. For total heating and cooling, it's at least 20%. But if you're looking at just heating, it's pretty major.
The ROI guys are just sighing a giant at that 4 feet of foam and 95% or 4 feet of insulation. Not foam, right, Dan?
Whatever. Yeah, I mean, you're talking about really low-hanging fruit here. Basement wall insulation, slab edge insulation. Well, slab edge is a lot tougher, but basement wall insulation is a huge one. You got to do that. Even if you're in an existing home and you've got shelving and stuff like that, I mean, if you can insulate those walls, it is a huge benefit.
Yeah, I still remember my 2008 built home. It was a larger builder, and looking outside after we got about 2 feet of snow and within about 2 days of 20-degree weather, and I had about a 1 foot ring around my house that was completely melted.
Yeah.
And me just starting with the company I'm with, Roxol at the time, I was like, I knew it was happening, and I just, it hurts you because that's your basement's basically a giant radiator at that point. It's warming the ground.
Yeah. One of the things that I think we have to overcome, at least in our market, is most people that grew up in this area probably grew up with a musty, cold basement. And so they don't have an expectation of comfort in that area. And so they're not really trying to wrap their head around, well, gosh, this could be so much better. They're just thinking, well, when I put the Christmas tree box down there, is it dry enough that I can walk across and get it later, or does the box fall apart?
Right.
That's their minimum standard. And so anything above that is like, oh, that sounds like an expensive ad, and it might get in the way of my, I don't know, my Caesar stone tops or whatever it is they're into. Everybody has their triggers, and when you get to build for a high performance client, and I really think that it's an important delineation. It's not just that there are people, everybody wants good things. Everybody wants to spend their money and get a good return on that investment and be comfortable and happy. But there's a really broad scale of expectation for at least the clients that I work with, where, some folks are really pretty satisfied if the windows don't blow a draft in. And then other clients are like, I could smell the food that I cooked yesterday. I really feel like the ventilation in here isn't adequate. And there's just a tremendous, I guess you'd say, wide chasm to meet those different clients in. So if there's anything that Neal and Josh could share with us in terms of how we can better sell foundation insulation to clients, I guess if they're coming to you as a high performance client anyway, that maybe isn't a hard sell. But if you can advise us, please do.
I don't know what to say.
Is that the good luck?
Good luck.
Well, we were just talking about that earlier because we were saying how in different markets you're going to have an easier time. Some people just expect it, and some people have never heard of it or think it, don't understand the value of it. So
Yeah. Go ahead.
I was just going to say, it just seems like these things just come down to education. So giving the people the right information to make the right decisions.
Absolutely.
Absolutely. Yeah. Some people come to us knowing something about building science and having some idea of what they're really looking for. But some people come to us and they say, hi, I'd like a new home and I'd like it to have this many bedrooms and, you know, these features. And we usually start those meetings with a building science presentation. Takes 10 to 15 minutes, but it's worth it then, because otherwise throughout design and construction, you know, you're almost like pulling in opposite directions. But once they understand sort of some of the pros and some of the benefits of it, and our past, a lot of our past clients, you know, who live in these houses, they come back to us and they're like, you have no idea what it's like to live in one of these houses. And it's like, it's so different. And these are clients who are coming from homes built in the late 90s. So not old houses, you know, like good houses, but it's just a completely different thing in high performance homes. You know, just the sort of the even temperatures, they're quiet, there's no drafts. You open the door and the wind doesn't blow in because it has nowhere to go because the house is air sealed. And, you know, the ventilation is, I think, one of the most undersold pieces. Just the fact that your house can always have like quiet, fresh air and doesn't have all those odors and, you know, so everything like that. But so I think the biggest thing is really educating clients. And I mean, money always comes into play. There's never a project that I've come across where there wasn't some kind of budget, some kind of give and take. But you know, at the end of it, it's just, you know, it's a comfort is, I guess, one of the biggest selling points. Because often, you know, if you can afford to build a really nice house, you could probably afford the heating bills.
Yeah.
You know, and so it comes down to, you know, I want to be comfortable, and I don't want a cold floor, or I don't want to, you know, have to go put on a sweater when I'm sitting on the couch, and, you know, sort of those things. And I guess a lot of those are some of the selling points.
Yeah, it does always seem to come back to comfort, especially as cheap as energy is around here. We just can't seem to motivate people that way. But you really have to stretch the imagination of some of these clients. So it makes sense that you're educating them first. I mean, you can never educate someone to a bigger budget. They're always you're like, well, I still need those 4 bedrooms and I still need the 3 bathrooms and I'm not coming off that kitchen island. So cool story about your physics, you know. There were a couple things in here regarding in the chat. Again, Armando was asking about the cost per square foot on basements versus slabs that you mentioned, Neal. You said the slabs were quite a bit cheaper. And I have also had a hard time with that. We have not found that we save a ton of money because we're already excavating at least 4 feet to get our footing anyway. How's that cost metric working out for you? Because that's what he's asking about.
To me, the big change has been the cost of concrete itself. The price of concrete, at least here, we used to buy concrete for about $53 a yard back in 2006, 2004, actually 2004. And right before it crashed, it doubled. It went to just over $100 a yard. And that was in just a couple of months. And that was back when steel tripled and everything like that. And that's when we knew the bubble was about to burst. That was in 04. And then it finally burst in really 07, 08. But yeah, that's the big difference. Concrete is really expensive. And excavation is a lot more expensive too. And getting rid of our rock or whatever that you have to haul it off to a landfill. It has to be dealt with. They charge a tipping fee. They charge hauling. Oh my gosh.
Don't forget winter charge. Everybody's got that winter charge.
Yeah.
You've also got framing your floor. I mean, if you're on a slab, you don't have to frame a
Yes.
floor system in, and then you got to set basement stairs and.
Yep. Yep.
Excellent.
Yeah.
Well, and really, you figure, since some of you guys are using frost-protected slabs, that just really wasn't an option in northern climates until we started having these types of insulation systems. So you were, like you said, you were digging a hole that deep anyway, but now you don't have to dig a hole that deep anymore.
It's an excellent point.
The other little caveat, I mean, even when you go from like a frost wall to just like an insulated wrap slab, you're cutting your amount of concrete down by 50%. And I don't know, in some places I'm starting to see a lot more carbon conversation, and it always seems to hit on concrete. And so that hasn't become a huge part of conversations with clients and here, but I see it coming down the horizon. And so less concrete,
There are other solutions for that too. I know we talked on the BS and Beer show on Thursdays about that about a month and a half ago. I think Carbon Cure was the one that I was most excited about.
Cool.
Just carbon storage within the concrete makes it a positive instead of a negative. So there are definitely a lot of options for that. There was one that, I don't know if you guys follow the Build Show Network. Steve Basic was on there the last few weeks doing a series on called the Perfect Block. It's basically a new ICF, but it's instead of being foam, it's foam concrete additive, and it has some of the termite resistance properties like Dan's product. It was basically, it seemed too good to be true to me. But I'm still watching the videos. I haven't seen the pour video yet. That's the one I need to watch, because that's always the issue with the ICFs in my world. Is I'm worried about the termites, and I'm worried about all the bracing that has to go into that. Because from what I've understood from my concrete guys, you spend so much time bracing it for your pour, you might as well have just formed up the walls for traditional concrete, because it's just such a risky assembly. But I haven't worked with it. I'm just telling you what I heard.
I have yet to use ICFs. I don't know. We have a very narrow specialization with these high performance homes. I mean, we do live in historic Cooperstown, so we relocate timber frames and do all kinds of stuff like that. But I mean, I have yet to touch ICFs, not because I have any aversion to them. They haven't come across on a project, and but yeah, no, I've been watching, on Instagram, Steve Bezek's, that Perfect Block wall. It looks like they're like cinder block. They look almost like concrete blocks, and it looks like they're laid very similarly. But yeah, no, it's always neat to see the different technology as it comes out, and then you kind of got to watch and see if there's any pitfalls as it sort of hits the market. You hate to be the first one that, yeah.
It's always scary to be the early adopter, right?
That's right.
Well, we do tend to let things peter out. If there aren't questions rolling in the chat box, then we will always wrap it up early. I thought Bill Robinson had something, but maybe he was. Oh, I think you already replied to him, Dan. Nice job. You guys are really on it. I don't have. Oh, the one other thing I wanted to ask you, Josh, before I let you go, was about that the skirt. The frost skirt you mentioned. I've seen a little bit of that through Randy Williams' Instagram. The benefits of that make sense in my mind, but I wanted to have someone more expert talk through the physics of that, and I'm sure you or Neal could do that. It's basically you're moving the air temperature that's affecting the ground further away from the house. Is that kind of the gist of it?
So frost likes to travel vertically. It does not like to travel horizontally. And the Earth has a temperature. I mean, the whole concept behind the geothermal, even whether you do vertical wells, or we see a lot more horizontal loops if you have a lot of land space, but they're buried 8 to 10 feet down, and that's enough to you'll have a ground temp of maybe 47 or something like that. But when we use that frost skirt, not only is it stopping the cold from being able to penetrate down, but you're also trapping the ambient temperature of the earth underneath it. And so it's kind of doing double duty there. And the frost doesn't really, it's unable to come down and then come in order to freeze, because it just, as soon as it starts to turn, it's being warmed up by all the ambient temperature below it. And so, yeah, frost skirts have been a way to get past, having to dig 4 or 5 feet down to to get below that frost line. So in our climate, you can get away with 2 inches. We use 3-inch just because our sub slab foam is also 2 layers of 3-inch. And so it's one less, separate quantity that we have to get on site just for a perimeter. That way we can just use the same. And it's also, when we're weighing risk in building assemblies, there's one thing where it's like, the trim might move and that might be a callback where we have to caulk something. It's another thing where, wow, my slab just cracked. Those are the risks that you mitigate to no end, because those are the type of things that damage reputation. I mean, how do you fix that in a building? I mean, so there's 2 different types of risk. There's the, sure, that's a callback, we can fix that. That was annoying, but yeah, no problem. And then there's the, wow, my foundation just heaved and now I've got a really expensive building that has a really big problem. So, those are the areas where you don't skimp and you don't play games.
Yeah, avoiding epic failure is a pretty high priority for all of us. I know that this is probably a solution in search of a problem type thinking, but when I saw that slab skirt detail, again, I was still thinking about my basements that I constantly have to pour to appease my clients. And so I was thinking, I've already got 3 feet for my overdig. So what if partway through my backfill, I just went ahead and put that skirt laying across there? Is that something I should consider, Neal, or am I wasting my time?
You're wasting your time.
Thanks. That's what I needed.
Just keep it on the inside and go all the way down.
I got you. All right. Well, I'm happy to wrap it up early. Everyone can, get to dinner with their families a little earlier than they would have if I was being long-winded. Unless anyone has anything else, Rob, are you looking at questions that I'm not seeing?
No, I don't see anything that was really pertaining to the conversation. I know that someone had mentioned earlier the complexity of doing a thin edge top of your slab to make room for the insulation, or of your footing wall. And someone, I think you answered that, didn't you, with the foam option?
Yeah, as far as blocking out for that top of wall connection in the pour. But I don't think their concern was so much structural about reducing the width of the wall. I think they were just saying that it's hard to get a clean edge there. Yeah, I would agree. If you ask guys to, trowel it out, that's no good. You guys are blocking out with foam, I imagine. Yeah. Yeah.
Yeah. Was that in reference to the frost wall and the double stud wall, or is that in reference to Neal's?
Your double stud wall, I believe.
Yeah, the double stud wall. So it's a 10-inch wall, which is plenty. And so we step it back to 6 inches. Just for that top foot. And we use foam to do that. You just cut 2 rips of 2-inch foam and slip it in there. And you never see it. I mean, so it doesn't have to be, pretty in terms of a nice, super clean transition, because it's just, you got sub slab foam that'll button to that, and you've got the concrete getting poured. And so, yeah, that's a really typical detail up here, because even if you weren't, say, doing a high performance home and you were just framing a 2x6 wall with maybe 2 inches of sub slab insulation, it's more common to see that sub slab insulation turn and come up and have a 45 chamfer inside the house. That's so something that you'll see. So.
Yeah, not exactly on that same topic, but on a similar note, when I first saw Neal's picture with the foam built right into the form, it just seems like such a smart thing, like not having to worry about how smooth the outside of the foundation is, because it's actually incorporated right into the pour.
Yeah.
Those are those details, like I was noticing earlier, that make all these jobs easier than they might seem like they would be.
Yeah.
Well, if there's nothing else, everyone want to go around the horn for parting words of wisdom? I'm all out of wisdom, so I'll kick it to someone smarter than myself. How about you, Neal? What do you want to say to everyone before we call it a night?
Oh, we always look for the low-hanging fruit, and people always ask me, what's the best thing I can do to increase the efficiency of my existing home? And they always want to put more insulation in the attic. And I always go, That's the best insulated part of your house. Even if you're only R19, it's the best part. Yeah, go ahead, but you're not going to get a whole lot. R60 versus R50, which the 2021 code in our climate zone is going to, it's a 0.5% improvement in your total energy. It's nothing. It's cheap and it's probably worth it, but come on, that's not a big deal. But you look at a basement wall or a slab edge and you're losing tons. Look for those things. Look for just a small hole, when you're doing air sealing can be huge. Those are the things. It's not the stuff that people think of right off the top of their head.
Yeah, I would agree with everything you said. I would say keep the details simple. It helps them get executed well. You always got to remember that in the field, that's where, I'm sure a lot of you are, it's muddy, it's raining, it's wet, it's and so anything that you might draw or come across the plans, it's always going to be a lot harder than that. And so keeping things simple, and just always planning ahead. A lot of the details are easy if you can plan them before you do them. It's when you've got a building kind of half built and it's like, all right, how are we going to address sub-slab insulation? Whoops, or where's my air seal, or, sort of all those things. And so foundations are no different. I think the one thing that was really in common between Neal's details and my details is that foam was there and ready before anything got poured, which it makes it easy. You could probably go around and stick it on later. It wouldn't be as good, but a little bit of planning and everyone's on board and it just goes in ahead of time. And, the concrete guys don't mind, and it's just definitely pays its dividends to plan these things out.
Making it easy for everyone to succeed does seem like a pretty solid shortcut to success. I would really like to just take another moment to thank you guys, Neal, Josh, Dan, Rob, everyone who took the time to join us tonight. I think this is a valuable conversation and really some actionable details we can all do a little bit better for not too much money and not too much effort. So thanks a lot for taking the time. We appreciate it.
Awesome. Thanks. Happy to be here.
Thanks a lot. Everyone have a great night.
Here, guys.